Here we're going to have a look at a calculation that's involved in the conservation of mass, and this is something that might also be called expected mass. It becomes quite important when we talk about atom economy and yield values, which come up in the triple and in the A level. But we're just going to have a look at a very, very simple way of calculating this that isn't really shown in most textbooks. Now, the law of conservation of mass is like the law of conservation of energy. It states that you cannot create or destroy mass, you can just change its arrangement. So I can't remove or add atoms to an equation, I just rearrange what molecules those atoms are in. That would be a chemical change. If there's no change to that, then it's a physical change, but we're really focusing on chemical changes here. So here's an example question for you, and let's highlight the numbers because I always like to do that. And oops, let's get rid of that. So we'll just highlight those numbers, and 3.2 grams of oxygen, and we highlight oxygen as well because it gives us our molecular mass, our MR. We've then got our equation, right? Now, something else that's important here in the equation is this, the number that comes before each molecule, because that's the number of moles that react with each other. So for every mole of oxygen, I need 2 moles of hydrogen. And that for every mole of oxygen, I will get 2 moles of water. And if we wanted to do this in the long-winded way that is suggested, or that most people will use, you would first of all have to find out the number of moles of oxygen, because it's the number of moles of oxygen they give you. So in order to do that, and there is a video on how to calculate the number of moles, you would do your mass, which is 3.2, and you would divide it, make that point a bit more obvious, you divide it by the MR, which is 32, which would give you 0.1 mole. And then, after you've done that, you would be looking to find out what mass of water is formed over here. So I then need to figure out how many moles of water I've got. So for every 1 mole of oxygen, I've got 2 moles of water. So if I've got 0.1 mole of oxygen, I have 0.2 moles of water. The MR of water is 16 plus 2 because the 2 hydrogens, so that's 18, and that's my mass, which is my grams. I need to rearrange that, so I've got grams equals 0.2 times 18, which in turn is 3.6. So therefore I would get 3.6 grams, and that would be my answer, right? And that would be how you would go about doing it. That's the sort of more expected way, that's a more conventional way. There is a really quick way of doing it, however. So there's a formula you can use, and the formula that I would give you is the MR of what you don't know divided by the MR of what you do know times the mass that you are given, right? So let's just figure out what those are. The thing I do know is the oxygen, and the thing I don't know is the water. So if I take this number here, the MR of this, and put it on the bottom, and the MR of this and put it on the top, I will get 18 divided by 32. If you're not sure where I got these numbers from, just go back to the slide, rewind the video. I'm then going to multiply it by the mass I get, which is 32, or 3.2, but hold on, because this has got twice as much. So I need to actually multiply this top bit by 2. So that's no longer 18, that becomes 36, right? So because of this number here, I'm going to multiply what's on top, x by 2. 36 divided by 32 multiplied by 3.2. If you want to put it into a calculator just to test me, you can, but that should be 3.6 grams.